Hey guys, how's it going? Alright, so let's look at some of these from the exercises. So find the value of each variable. If your answer is not an integer, leave it in simplest form. So this is 7-3, special right triangles. We have a 45, 45, 90 triangle. I'm going to solve for x and y. This is isosceles, so x is going to be the same as the other leg. And then y, according to the theorem, is going to be 8 times the root 2. Alright, next one. Let's move on to 5. 5, I don't know what they're trying to do. They're trying to trick you. They drew the triangle at a slant. It's still a 45, 45, 90. Okay, this time we have the hypotenuse already. So the hypotenuse is equal to the leg times root 2. My hypotenuse is 8. So to solve for this, I need to divide 8 by root 2. And I can't leave that in that form, so I'll multiply the top and bottom by root 2. So my leg is equal to 4 times root 2. Yeah, these are all more the same. Let's look at number 11. Helicopters. The 4 blades of a helicopter meet at right angles and are all the same length. So here's our helicopter blades. They all meet at right angles. The distance between the tips of 2 adjacent blades is 36 feet. So 2 adjacent means they're next to each other. The distance from the tips is 36. How long is each blade? Round your answer to the nearest tenth. So this is a 45, 45, 90. Okay, since these are the same length, so we want to find out the length of each. So my hypotenuse, again, is going to be equal to the length times root 2. My hypotenuse is 36 feet. So I just need to divide 36 by root 2. And then I can't leave that in that form, so I'll multiply the top and bottom by root 2. And then divide that. So each blade, oops, sorry about that. Each blade is 18 times root 2 feet, and we're not going to leave it in that weird form when we're talking about real life stuff, since you can't just tell a pilot that your blades are 18 root 2 feet. So you plug it in a calculator, and what do they want? Nearest tenth. So the blades are 25 and a half feet long. Alright, number 13. Find the value of each variable. If your answer is not an integer, leave it in simplest radical form. So here we have a 30, 60, 90. This is 60, this is 30. This is 2 root 3. Okay, so the hypotenuse is 2 root 3. The hypotenuse is equal to the short leg times 2. So my hypotenuse is 2 root 3, which is equal to the short leg times 2. So if I'm solving for the length of the short leg, I need to divide by 2. So my short leg is equal to root 3, so that's x. And then my long leg is equal to the short leg times root 3. So my long leg is equal to, in this case I have root 3 times root 3. When you're multiplying 2 of the same square roots together, it simply equals that number. So the long leg y is equal to 3. Let's move on to number 15. Find the value of each variable. Leave your answer in the simplest radical form. So this is a 30, 60, 90. So my short leg is equal to 12 units. So my hypotenuse is going to be 2 times the short leg. So the hypotenuse here is x, so that's 2 times 12. X equals 24. The long leg is going to equal the short leg times root 3. And so y, which is the long leg, is equal to 12 root 3. So we're done there. Let's do 19. So I have a 30, 60, 90 again, looks like. Yep. My long leg is 9, hypotenuse is y, short leg is x. So since I have my long leg, I'll start by solving for the short leg since there's a direct relationship between the long leg and the short leg. So the long leg is equal to, and the easiest way to do these is just to write out the formula each time. It doesn't matter what your starting point is. It'll help, trust me. The long leg is equal to the short leg times root 3. My long leg is 9. I don't know what my short leg is. It's x times root 3. So x is equal to 9 divided by root 3. I'm going to multiply the top and bottom by root 3. So x equals 9 root 3 divided by 3, which equals 3 root 3. So that's x. Now the hypotenuse is equal to the short leg times 2. So in this case, the hypotenuse is y. So it's going to be the short leg, which is 3 root 3 times 2. So y equals 6 root 3. Alright, we'll do the last one. I'll do 21 and 23. Find the area of each. Round your inch to the nearest tenth. We want to find the area of an equilateral triangle with sides of 10. Okay, this is equilateral. So I need to find the area, so I need the height. That's going to be that guy. When I make that altitude, this splits it into a 30, 60, 90. Short leg is going to be 5 and 5. So my hypotenuse, let's see, so I'm trying to find area, so I have 1/2 times base times height. My base here is going to be 10. The base equals 10. That's this bottom length here. My height is what I'm trying to solve for. So that's why I split the triangle, this equilateral, into a 30, 60, 90, so I can solve for this height. The height will be my longer leg, and that's going to be your shorter leg times root 3. So my shorter leg was 5, that's when I split it in 2. So this height here is 5 root 3. This is my height. So I plug these in. Area equals 1/2 times 10 times 5 root 3. And it says round to the nearest tenth. So that's 25 times root 3 is 43.3 centimeters squared. Next we'll do number 23. We're looking at a rhombus. So remember, a rhombus is a parallelogram with 4 equal sides. It's got a 45-degree angle and sides that are 12 meters long. So let's do a rhombus here. It's got a 45. Okay, so how do I want to draw this? So remember, opposite vertices of a rhombus are the same. So this is 45, and this is 45. These two are supplementary. So that makes this one 35 and this one 35. I'm not sure if we need to know that yet. So I have my rhombus. Let's see, what are we doing here? How can I find the area of this? Thinking. My guess is that I'm going to use the 45-45-90 theorem. Let me pause this video.